It's easy enough to determine whether a quadratic function has a minimum or a maximum value without graphing it simply by looking at the equation. Down here I can see that my quadratic, my parabola, is going to open upwards because I have a positive 3a value. So I know that my parabola would look something like this. Well, sketching it out like that makes it pretty clear that I'm going to have a minimum value. The vertex will represent a minimum for this graph. So this graph, and anything with a positive a value will have a minimum, anything with a negative a value would have a maximum. To find it, I'm going to go about this just like I would do with finding the vertex, because really the minimum value is going to happen where the vertex occurs. So there's various ways I can do this in the calculator, and if you know how to do that, great. I'm going to focus on just doing this by hand though. So I'm going to use the formula x equals the opposite of b over 2a to at least begin this problem. So since b is negative 18, the opposite of that's positive 18. I'm going to divide that by 2 times the a value, which is 3. That gets me 18 divided by 6, which just simplifies to plain old 3. Now that's not the minimum. Instead, that's where the minimum will occur. The minimum will occur when x is equal to 3. To actually then find the y value of the vertex, which is in fact just the minimum value, I'm going to plug 3 back in for x and figure out what y would be. So plugging in 3 for x, I would get 3 times 3 squared minus 18 times 3. And then plus 20. Either be very careful following order of operations, or you can go ahead and just type all that in. I see that I get a y value then of negative 7, which is really exactly how we found the vertex before. The vertex of this parabola is 3, negative 7. When they ask for the minimum value though, technically speaking, all they really want is just the y value. So the lowest point that this parabola gets to is negative 7. The minimum is negative 7.